Today we're going to be talking about internal and external linkage in C++. So here I have a simple example. Before I get to this example, let's talk a little bit about C++. In C++, each .cpp file becomes its own translation unit. This is very important to understanding internal and external linkage. The fact that each CPP file becomes its own translation unit. The concept of translation unit does not exist in Java. It's a C++ specific thing. So basically, what is a translation unit? It's each .cpp file plus the pre-processing of all the includes. This becomes one translation unit, and this becomes one translation unit because they're different CPP files. You see, I have main.cpp and module.cpp. Each becomes its own translation unit. The compiler compiles main.cpp separate from module.cpp. It's important to keep this in mind, that the compiler compiles them separately. Okay, and then after the compiler compiles them, the linker connects the names used in one file with the definitions in another. For example, you see this method right here, add. This is a forward declaration of add to tell main.cpp that basically somewhere in the code base, this function exists. So you could say this function exists somewhere in the code base. You can think of forward declarations like that because it's in a different file and the compiler is not aware of the other file at the time of compilation. Okay. Okay. So how does this compare to Java? Well, it's already a lot different because in Java there is no linking. You don't have to think of it at the source level. It's all just kind of um, tied together by the JVM, so you don't even have to worry about the files and the linkage between the files. Okay, so let's compile and run to see what happens. Okay, so it just printed here, add 2.5, and then the result of add. So it was able to find this add method over here. So this feels a bit like Java method calling another class, but the mechanism's totally different. So Java resolves with the class model and bytecode linking. C++ resolves across translation units with a linker. Okay, so I keep saying linker. Okay, so now we're going to talk about internal and external linkage. So first, let's talk about external linkage. So functions are external by default. So when you say that, for example, this works because functions in C++ have external linkage by default. So main.cpp only needs a forward declaration, for example. The linker finds the real definition in module.cpp. Okay, so internal linkage now is something different. So it's basically similar to the concept of file private. And let's see an example. So I'm going to add a static keyword here to the add. Okay, so there's static. So when I add the keyword static, it's actually going to give this method internal linkage. So this means it's only visible inside module CPP's translation unit. Okay, so it's no longer going to be resolvable by this forward declaration by the linker. So even though the compiler thinks that add exists, once we get to linking, it's going to be a problem. So here, let's just compile. Okay, interesting. Linker command failed with exit code 1, because this does compilation and linkage. So in Java, you don't have the exact equivalent of this across files. The closest intent would be making a helper private, but in Java, that's enforced by the class system. So it's completely different. There's no linker and there's no, yeah, there's no linker really. That's the main point. Okay, so let's look at something different. So here, let's see this add method. Let's put it into a namespace. So this is actually like a modern internal linkage style. So let's put it inside namespace. So it's no longer static, and we're going to put it in a namespace. Let's fix the indentation so it's more like understandable. Okay. So this is called an unnamed namespace. If you can see, there's no name to the namespace. So C++, like in recent years, they prefer unnamed namespaces over static because it has the same effect as internal linkage, and it's still invisible to other translation units. So let's compile again, and it should result in an error because this is an unnamed namespace, and it's very similar to static. So you see how it has the same exact error. Linker command failed. It's the exact same error, but just people don't like using static anymore for this use case. Okay, so let's fix it back so that it's in a working state. So here, let's get rid of the namespace and the static so that we had. So let me ask a question before proceeding. Will this work? Will the linker succeed in this case? Well, the answer is yes, it will work because now this is back to having external linkage because there's no static and there's no unnamed namespace. So this method is visible across the files. Okay, so let's compile it. Okay, and it should work. Yep, demo. Okay, so it works. Okay, so now let's do a slightly different example. So include IO stream. Let's do int get module number. So this is going to be defined in module.cpp. Okay, and then let's do namespace int file number equals 10. So this is obviously internal to main.cpp because it's an unnamed namespace. I think I'm missing something here. Oh, I'm missing the semicolon over there. All right, so int get main number return file number. Let's say main file number. All right. All right, let me expand this a little bit so you can see what I'm doing. All right, so now we're going to replace module CPP with also an unnamed namespace, just like this. So this is not visible to main.cpp, it's only in module.cpp. And then we have int get module number, basically the same idea. Return file number. All right. So you can probably already see where this is going pretty easily. So these two variables have the same name, but each is internal to its own translation unit. So int file number and int file number. They both have the same name, but they're internal to each their own translation unit. So this is internal to module CPP translation unit, and this is internal to main.cpp translation unit. So there's no naming collision if you think about it. And each file gets its own private file number. Okay. So this is the clearest way to really understand what internal linkage means. Okay, so let's compile and run. Okay, so the linker command failed. Undefined symbol. Interesting. I think I just didn't save the file. Okay, that worked. Now I just didn't click save. That's why that happened. So now let's run. Okay, so let's compare what's happening here. So okay, first of all, it's just printing out file number um, from this method, and then from this method. It's pretty obvious what's happening. Okay, so in Java, we usually aim for this kind of encapsulation with private fields in different classes. Okay, in C++, you can accomplish the same thing with translation unit level encapsulation. Okay, so let's talk about external linkage for variables now. So let's talk about module.cpp. Let's say int shared number equals 123, and then int get module number, return shared number. That's funny. Shared bumper. Return shared number. And then main.cpp. We're gonna add a keyword in right now that's gonna be kind of interesting. So let's say extern int shared number. Notice this extern keyword. It's pretty interesting. So then you have int get module number, which is a forward declaration that points to this file right here. And then extern, you're going to see in a second what that means. So let's say shared number from main equals shared number. And then shared number from module equals, or let's say via module, not from. It's more clear. Get module number. Okay. So basically non-const globals have external linkage by default. Okay, I'm going to say that again. Non-const globals have external linkage by default. So it's used in another file. So this is non-const. Okay, and it's global scope. And we have an extern keyword. Why? Uh, because we can just basically like access the same number. If you click here, so I'm doing command and click, and it's going to take me to module.cpp. So even the IDE recognizes the extern keyword. Like let's remove the extern keyword here and then try to do command click. It doesn't go anywhere. But if I add extern and I click here, the IDE takes you to module.cpp because the module recognizes the extern keyword and that non-const globals have external linkage. Okay, so let's compile and run. It should work without any issues. Okay, actually it didn't work. Okay, so why did it not work? undefined symbol, shared number. Okay, once again, I just didn't save the file. I just need to click save and that's it. So it works fine, as expected. All right. All right, so now I'm gonna cause, or I'm not gonna say what I'm gonna do. I'm gonna do it and then I'm gonna surprise you. So let's say here I have this. I remove the extern keyword and I go here and I put 777. So equal 77. Okay, so this is no longer a declaration now, it's a definition. Previously, it was a declaration. Let me just put it here so it's more obvious. Okay, here you go. I'm going to comment this out, and then I'm going to do int shared number equals 777. So compare the one that's commented out to the one that's not commented out. This is no longer a declaration. This is a declaration, but this is a definition. So now both files define shared number, and there's external linkage with two definitions. So there should be a linker conflict because there's an external linkage plus two definitions. So let me see what happens actually. Okay, exactly. Duplicate symbol. Duplicate symbol. So Java mostly would prevent this category of error through its class and package model, but in C++, you're responsible for ensuring one external definition across the program. So since this is an external definition with external linkage, you only can have this identifier defined one time across the entire program. So, I mean, some people like to do G underscore like global, um, but that's not a big deal right now. So main CPP, let's edit it back to extern. Let me just uncomment actually. So here we go. So now we should be back to the expected result because now there's only a single definition of shared number. And this extern keyword makes it so that it knows to go to module.cpp. So basically each CPP file is a translation unit compiled separately. You need to remember this is compiled separately than this. There's a compiler, then there's a linker. It's two steps. And linkage basically answers a question. It says, is this name the same entity across translation units? So is this name the same entity across translation units? And the extern keyword makes it so that it knows that it is. So internal linkage would be file only identity, and external linkage is program wide identity. Okay. So functions default to external linkage, and you can use static, remember, or unnamed namespace to give internal linkage. And for globals, there's one definition per CPP. Well, no, there's for globals, there's only one definition for the identifier across all CPP files, but you can refer using extern, for example, to that definition here, like that. And if you define the same external global twice, you get multiple definitions error, like you saw over here, duplicate symbol, so multiple definitions error. And if you try to call an internal function from another file, you'll get an undefined reference. Yeah, that's it for this topic. Simple enough, right? Thanks, guys.